Hello, Math 130 students. We are going to pick up on page 19, section 7.6, solving quadratic inequalities. So hopefully you remember what inequalities mean. Here is a short little index, the less than, greater than, and we also have the less than or equal to and the greater than or equal to. So for the first example, it says solve by graphing, then write the solution in interval notation. Well, interval notation, in case you have forgotten, always goes from your smallest value to your biggest value. And it can either be parentheses, it can be brackets, it can be a parentheses and a bracket, or a bracket and parentheses. And it kind of just depends on the symbol, whether it's strictly less than, or if it's less than or equal to, or greater than, and the last one greater than or equal to. So if it's something like this, I'm going to have brackets when it has a line underneath it. No line underneath it is going to indicate parentheses, okay? All right, so if I'm going to solve by graphing, the first thing I want to do is graph this. The first thing maybe that I want to do is find the x-intercepts. So if I find the x-intercepts, I have x squared plus 8x plus 15 equal to 0. So if I were to factor this, I have that 5 times 3 is equal to 15, and it adds up to 8. So x plus 5 is equal to 0. So x is equal to a negative 5. X plus 3 is equal to 0. So x is equal to a negative 3. So I have a negative 5 as one of my x-intercepts, and I have negative 3. Another thing that I can do here is find my vertex. If I were to find my vertex, remember it's my h and my k value, and I can find my h value by my negative b over 2a. In this case, it would be a negative 8 over 2 times 1. So negative 8 divided by 2 is going to give me a negative 4. So if I plug that into my original equation, so that I have negative 4 squared plus 8 times negative 4 plus 15, that gives me a negative 1. So I know that my vertex is negative 4, negative 1, which is right here. So now I know more or less that my graph looks like this. So when it specifically is asking me to write this in my interval notation, well, for interval notation, this is what I'm looking at. I'm looking at greater than or equal to 0. So if it's greater than or equal to 0, it's telling me that my values on my graph are going to be positive. So here, my positive graphs is here and here. So I need to represent that. So in interval notation, that goes from negative infinity to a negative 5. And at negative 5, it's a bracket because it's a filled in closed circle, and I have is greater than or equal to 0, union, and that next piece is my negative 3 to my positive infinity. So that ends up becoming my interval notation. Okay, so now let's think about the second one. So here I'm going to go ahead and factor out a negative 1. So I have a negative 1. Now I have an x squared minus a 2x minus 24 is going to be less than 0. So if I'm looking for my x-intercepts, then I have negative 1. I'm going to go ahead and factor and set this equal to 0. So two numbers that multiply together to give me 24 and gives me 2 would be a 6 and a 4. So I'd have that x minus 6 is equal to 0. So x is equal to positive 6. X plus 4 is equal to 0. So x is equal to a negative 4. So I have a positive 6 as my x-intercept, and I have a negative 4. Now for my vertex, remember for my vertex, I'm looking at that negative b over 2a. So here, that value for my b would be a positive 2. So then my a value would be a negative 1. So I'd have negative 2 as my numerator, and I would have a negative 2 in my denominator, which ends up giving me a positive 1. So my vertex, I have 1 as my h value. So if I plug that into my original equation, negative parentheses 1 squared plus 2 times 1 plus 24, that gives me a 25. So 1 over 25 is going to be my vertex. So that is going to be way up here. So let's just say this is going to go something like this, right? It's way up high. And we also want to give this an interval notation. So since this is specifically asking me when it's going to be less than 0, one of my values is going to be negative. Well, that's here and here. So I'm going to say between negative infinity to a negative 4, union positive 6 to a positive infinity is going to be my interval notation that's going to represent where this entire graph is negative. Notice how I put parentheses around the 4 and the 6, and that's because it's strictly less than. If I had a little line underneath it where it was less than or equal to, then it would change it to a bracket. But since it's strictly less than 0, then I'm going to need parentheses there. Okay? All right. Now, for the next example, it says to solve algebraically. So now I'm going to be thinking about doing the same thing, except now it's going to be slightly different because I'm going to be doing something called a plus or minus chart, okay? So first thing first, I want to set this equal to 0 so I can find my critical values. So I have 2x squared plus 4x plus 9 is equal to 0. So whenever I have a degree 2, in order to solve this, I'm going to try to factor. And if factor doesn't work, then we can always fall back on the quadratic formula. So I'm not sure if this is going to factor, but I'm going to try. So let's do this guess and check. So it would be a 2x times an x. So 9 can be broken down as 3 times 3. So that would give me 6. But 6 minus 3 is 3. It does not give me a 4. And if I gave a 9 in there, that would be too big. So here, the factoring doesn't work. And I did the guess and check, and that's what you do with the guess and check method. You guess it, and then you check it. So I checked it, and it didn't work out. So I know it's not going to factor. So instead, I'm going to go into my quadratic formula. So I have my negative b plus or minus b squared minus 4ac all over my 2a. So the b value that I'm plugging in here, or actually my a is a 2, my b is a 4, and my c is equal to 9. So that b value that I'm plugging in is a 4. Now I'm going to do my discriminant, so b squared minus 4ac. When I plug that all in, I'm going to have a 4 squared minus 4 times 2 times 9, which gives me a negative 56. And my a value was a2. So this gives me negative 4 plus or minus, and since it's negative inside the square root, I have an I, and the square root of 56 gets broken down as 2 square root 14. And I have 4. So now I have this as a negative 4 over 4 plus or minus, and here I can simplify. 2 goes into 4 twice. So I'm going to have a square root 14 over 2. And better yet, I will have a negative 1 plus or minus the square root of 14 over 2. So I did not give myself enough room, but that's okay. So now, at the very least, I have my critical values. So I'm going to plug this into my number line. And maybe I want to know the negative and the positive of that. So negative 1 plus the square root of 14 divided by 2, and negative 1 minus the square root of 14 divided by 2. So I specifically want the decimal approximation. And I am forgetting the imaginary part here. Don't forget about that. That is very important. So I'm going to have an imaginary number here. So because we're dealing with imaginary numbers, we are actually not going to have our decimal approximation here. And I have to remember that when we're specifically talking about these types of problems from the very beginning, it wants to know what values, when I plug it in, will make this less than 0. Well, the fact that these are imaginary numbers, right, because I have that negative inside the square root, there isn't anything that's going to make this a true statement. So we are going to say this. You might be thinking, well, what the heck does that symbol mean? It means no solution. Okay. So let's try that again with part B. Let's see if it works a little bit nicer in part B. Okay. So for part B, I'm going to try to see if I can factor this. Well, I know there's a GCF of a 2, so I'll start there. So I have an x squared minus a 5x plus 6 is going to be, that's supposed to be a bracket there. There we go. Greater than 0. Or actually, since I am factoring, I'm going to go ahead and set it equal to 0 so I can find my critical values. So I can factor this a bit more. I can have x times x. And two numbers that can add up will give me a negative 2 and a negative 3. Negative 2 plus negative 3 is a negative 5, and negative 2 times negative 3 is a positive 6. So now I have that x is equal to a positive 2 and x is equal to a positive 3. So on my number line, I have 2 and 3 as my critical values. So I'm going to see whether or not I'm going to have positive or negative intervals. So I don't know, here let's let x is equal to 0. If I let x equal to 0, what type of value am I going to get? Well, I would get a 2x squared minus 10x plus 12. So if I plug in a 0 here, I would get that my value is going to be a positive 12. So I would write in there a positive. Now let's try it again for a value in between here. So let's say some value between 2 and 3. So why not 2.5? So let's plug it into our equation. So we have a 2 0.5 that I'm going to be plugging in. So I have a 2 parentheses 2.5 squared minus 10 times a 2.5 plus a 12. That gives me a negative 0.5. So that's going to be a negative value. So now let's pick a number over here. So what about x is equal to 4? So now let's see what happens when I plug 4 into this equation. See if I get a positive or a negative. So if I plug in a 4, let's see what ends up happening. So 2 times 4 squared minus 10 times 4 plus 12 gives me a positive 4. So that's going to be positive. So since it's specifically saying that I want it to be greater than 0, that means you want positive since it's greater than 0. And since it's, well, if it was like this, then I know I would be using brackets. But since it's like this, I'm going to be using parentheses. So it specifically wants our positive intervals, so that's here, which goes off to infinity, and here, which goes off to infinity. So I'm going to write that as my interval notation. So from negative infinity to a positive 2, union 3 to a positive infinity. So that ends up becoming my final answer. So I can do the same thing here with letter C. So I'm going to go ahead and add 2 to both sides. So now I have x squared minus 8x plus 2 is greater than or equal to 0. So then from here, well, I know that it definitely cannot factor. So I'm going to have my a equal to 1, my b is equal to negative 8, and my c equal to a positive 2. So that I have a negative b plus or minus the discriminant over 2 times my a value. So I know I have negative 8 and a positive 1. So that discriminant is negative 8 squared, because that's my b squared, minus 4 times my a times my c, and I end up getting a positive 56. So this gives me 8 halves plus or minus, and the square root of 56, well, that's the same as saying 2 square root 14. So now I have 4 plus or minus the square root of 14. So if I'm going to graph this on my number line, so I'm going to have two values. So I'm going to have 4 plus the square root of 14 as a decimal, which is going to be my 7.74-ish. And now I'm going to do the negative of that. So 4 minus the square root of 14, and that is going to be a 0.258. Okay, so it's always nice to put the decimal approximations, so that way you know what the heck you are plugging in for your values, okay? So now let's check some of these intervals. So we are going to be checking for, it looks like greater than or equal to 0. So we're going to be looking for our positive intervals again, okay? So for here, let's plug in some values. So how about here we let x equal to 0. So I have the general equation x squared minus 8x plus 2. So that x value of 0, when I plug that in, that gives me a positive 2. So I have a positive here. So how about here we plug in x is equal to, let's say, 1, since 1 is between these two values. And 1 is a nice, easy number to plug in. So that I have 1 squared minus 8 times 1 plus 2, and that gives me a negative 5. So it's a negative that I have there. And now, for that last answer, or that last bit, let's have x is equal to 8. So if I plug in 8 into this equation, I would have 8 squared minus 8 times 8 plus 2, which is a positive 2. So now, since I'm looking for my positive intervals, that's here and here. So I'm going to be representing that as a negative infinity to a 4 minus the square root of 14, bracket, union, and it's going to be a bracket 4 plus the square root of 14 towards a positive infinity. And so that ends up becoming my final answer for part C. Now for part D. So I want to make sure that I get it equal to 0, so I'm going to subtract 1 from both sides. So that x squared plus 7x minus 18 is equal to my 0. So I'm going to see if I can factor. I'm not sure. So if I'm looking at the multiples of 18, I have 1 times 18, 2 times 9, 3 times 6. And I believe that is it. So the only combination that's going to give me 7 is that 2 and the 9. So I have x, I'm going to have my 9 and my 2. So it would be a positive 9 and a minus 2. So 9 minus 2 is a positive 7, and positive 9 times my negative 2 is a negative 18. So now I have that x is equal to a negative 9, and x is equal to a positive 2. So those are going to be my critical values. So if I were to plot them, here's negative 9, and here's my positive 2. Now I'm going to be plugging this into x squared plus 7 times x minus 18. So let's start here. So maybe we want to start with x is equal to a negative 10. Let's see what happens when we plug that in. So negative 10 squared plus 7 times my negative 10 minus 18, that gives me a positive value. Now let's see what happens when I plug in something else. So how about we plug in x is equal to 0 here, since 0 is between negative 9 and 2. Well, that's going to give me a negative 18, so that's going to be a negative value. Now, let's pick, I don't know, x is equal to 3. So if I pick a 3 in, so I have 3 squared plus 7 times 3 minus 18, that gives me a positive 12, so it's positive. And here I'm looking for x squared plus 7x minus 18 less than or equal to 0. So since I'm specifically looking for less than or equal to 0, I'm looking for my negative values. So I'm looking for my negative interval. So my negative interval is here. And since there's a line underneath it, I'm going to include where it is exactly equal to 0. So I have my negative 9 bracket to a positive 2, where indicates my values that are going to be less than or equal to 0. If you guys have any questions, please feel free to email me, contact me, the Math Success Center, and our amazing embedded tutor. Thank you.